Hi everyone, welcome to section 4 of chapter 9, using the financial calculators. So we're finally going to use these financial calculators for what they were made for, making calculations with compounding interest, very straightforward. So it's quicker and definitely less prone to error, and it's a good idea to learn both methods just so you can get used to checking and making sure that one, that they work out the same, and two, to see the reasonableness of the answer. Okay. So as you saw in my intro video, that there's a row, the third row in the BA2 plus, and it's the first row in the Sharp calculator where your 5 main buttons are. So we have the number of compounding periods, which is your N. Your IY is what J was in your manual calculations, okay, the nominal rate or the annual interest rate. We have the present value, PV. We have a future value, FV. We haven't used the PMT button yet, but we will in coming chapters. What this is instead of having 5,000 that we're going to invest to get a future value, or how much do we need to invest today in order to attain a future value? What if you had a mortgage and you made payments throughout so that you could make your future value 0 at the end of the mortgage? Or what if we invested in mutual funds or registered retirement savings plans, and we actually made payments every 2 weeks towards our retirement fund? Okay, so that's what the payment is, and we will get to that. Okay, so you will see as well that once we go to put in the IY, the annual interest rate, it's the percentage. So if it's 6%, we're going to put it in as a 6, but not with the percentage sign and not turning it into a decimal. Okay, so as you saw, this is our financial calculator. Row 3 is where all of our key buttons are. So again, you can get to these slides from the previous section. So Unit 4B, that's where the slides for Chapter 9 are. So if you want to have another look at this, or just pause the video, and it shows you and tells you exactly what each of the buttons is for. Okay, so let's give it a try. What amount must you invest now in order to have 5,000 in 3 years' time, assuming a rate of 6% compounded monthly? Okay, so as I've mentioned before, the best thing you can do is write out what you know, okay? So right off the start, we can figure whether we're trying to figure out a present value, whether we're trying to figure out a future value. Or maybe, as in future questions, we're going to try to figure out the payment. Okay. So we know that the future value, because we want to have 5,000 in 3 years, so the future value is 5. We know that the number of compounding periods is 36 in total, 3 years at 12 per year. The J, or the IY, is 6%. The compounding periods per year, and we'll see how to get to the CY, is 12. And the present value is the one that we don't know. Okay, so let's give it a try. So what we do is when we're using our calculator, we actually put the number in first. So we're going to click 36, and then we're going to hit N. We're going to hit 6, which is our annual percentage, and then we're going to click IY. 0, even though we don't have any payments, we still have to acknowledge. So we have to put 0 payments. Otherwise, it'll think that there are 2 factors that we don't know the answer to, and it won't be able to solve. So 0 payment, and then 5,000, we know that is our future value. Now here we haven't tried this yet, so we want to click the second, okay, and then we're going to click IY to get to the PY. And then we're going to put 12 for our compounding periods per year. So it's 12, 1, 2, and then enter. Your enter button's up here. Okay. And then we're going to go second. We're going to click the second button again. And then we're going to hit the compute, because what we're trying to get to is the quit. So we're going to go second quit, and that's going to take us out of that second level and bring us back to the forefront. And then we're going to hit compute, and then we're going to hit present value. And that is going to give us a present value of $4,178.22. As you can see, the present value comes up as a negative, and the future value has been put in as a positive. But if we had put in that 5,000 as a negative number, then the present value would have come up with as a positive number, okay? Think of it as money going out and then money coming in, okay? So it says how much must you invest now. So if you're investing it, you're going to take it out of your bank account and you're going to put it into an investment. So that's going to be money coming out of your bank account, okay? And then in the future, 3 years' time, you're going to have that 5,000 to put back into your bank account, okay? So there's the two different directions, and that's what is represented by a negative and a positive number. Okay. So here's a little bit of a different one, okay? So we're trying to figure out what single payment 4 years from now can replace the two payments, okay? So we have payment. First thing you need to do is draw your timeline, okay? So we're looking at payments of $1,300 due today and $1,800 due in 1 3/4 years are to be replaced by a single payment 4 years from now. So we want a timeline for 4 years. You always have a 0 because that's today, okay? And we have the $1,300 that's due today. Nothing at the 1 year mark. And then at 1 3/4 years, we're going to pay $1,800, okay? So then you can see that there's going to be a future value of the $1,300 that we need to compute, and there's going to be a future value of the $1,800 that we need to compute. So the 13 is going to be invested in for 4 years, and that 1,800, because it's due at 1.75 years, it's going to be invested for 2 1/4 years, okay? So we put it in at 1.75, so therefore in 2 1/4 years, that'll bring it up to the 4 year mark. Okay, so what is the amount of that payment if money is worth 2% compounded quarterly? So we need to compute the future value for each individual payment. So look at it as two separate ones, and then we're going to add them together. Okay. So we'll start with the 1,800 because that's only going to be invested for 2 1/4 years. So we have a present value of 1,800. Our N, the number of compounding periods throughout the life, is 2 1/4 for the number of years multiplied by 4, which is the compounded quarterly, and that gives us 9. We know that our annual interest rate is 2%, and we know that it's compounded per year 4 times, and we don't know what the future value is. So let's look at the 1300. We know the present value is 1300. We know that the number of periods is 16, 4 years times 4 for being quarterly. 2% is your IY. Compound per year is 4. And what is your future value of this payment? Okay, so let's give it a try. So we've got 9 for our N, 2 for our interest rate per year, 1,800 for your present value, 0 for our payment, and we need to go second, and our IY to get to our PY. And then we're going to go 4 and then click enter. And then second, and then we need to hit the compute button to get to the quit. That'll bring us back to the top level of our calculator. And then we're going to compute our future value, which is negative $1,882.64. So again, you can see here your present value was 1,800. So our future value is negative 1882.64. Now we have 16N, 2 IY, 13 present value, 0 payment, and then again we need to go to the second, IY to get to the PY. We're going to put in the 4 again and then enter because it's still compounded quarterly. And then second, compute to get to the quit so that it brings us back to the main level in our calculator. And then compute future value. And then the future value of the 1,300 invested for 4 years is $1,407.99. Okay, so if we added those two together, if we did a single payment 4 years from now, we could give them $3,290.63, and that would be the equivalent of paying $1,300 today and $1,800 due in 1 3/4 years. Other applications, the guaranteed investment certificates, GICs, strip bonds, promissory notes. They're a common type of investment that has compounded interest that Canadians do invest in. And we can apply what we have learned so far to these investments and the concept of inflation. We will stop here and pick up from here soon. Thanks, everyone.